Yeah, hello students, and today we are going to be discuss about 3rd September assignment for our senior N-40 and N-Chaina students, right? So the first question, if you observe the question number one, which is given in the schedule, that is fluorine stabilizes highest oxidation state due to its high lattice energy in case of, just look at here, very important thing, in 3D series or any series from scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, like that. From left to right, size decreases so that enthalpy of bond energy, or we can say that lattice energy increases. We know that lattice energy is inversely proportional to the size, right? So here too their lattice energy increases because size decreases. So in the given thing, vanadium, chromium, cobalt is given. Okay, vanadium, chromium, cobalt is given. Cobalt is having the what? Least size and more lattice energy, so that it is stabilized by lattice energy. This is a that is given in the schedule. And if you move to first question in the given thing, first question over there, in additional questions, the stability of the fluorine to stabilize highest oxidation state due to its lattice energy, same thing is given, and the answer is also COF3. COF3 is the answer. If you observe the second question, the basic character of the monoxides of the transition series in the following order. Don't forget that if you given thing, titanium is given, after that vanadium is given, after that chromium is given, after that iron is given. Don't forget that here to here size decreases, non-metallic character increases, where metallic character decreases. Metallic character decreases, basic strength also decreases. Don't forget that basic strength decreases. So here basic strength will be more, here basic strength will be less for those oxides. So that's why this is thing which is given in second option. That's why for the second option is correct. If you move for the third question, transition elements usually exhibits a higher oxidation state in. Don't forget that transition elements are stable with oxygen. Reason, oxygen can form multiple bonds. It can form multiple bonds. When oxygen is forming multiple bonds means fluorine cannot form, even though fluorine is higher strong oxidizing agent. Fluorine can form single bond, where oxygen can form double bond. That means with less number of oxygen atoms, more valency is possible. So that's why oxides is correct for fourth thing. If you are go to fifth question, if you are moves to the fourth question, so third is over. So if you move for fourth question, just look at here what happened here. The fourth question is, what is the fourth question given over there? Chromium, manganese both have D4 configuration, hence we know that which is given, chromium plus 2 is given. So that what is chromium plus 2 means, we know that 3D4, and where chromium plus 3, we know that 3D3. What's the meaning of 3D3? Is nothing but T2G3, means it is completely half-filled stable compound. That means it is unstable. This is unstable because it is not having full-filled or half-filled electronic combination, but it is having half-filled of T2G3. So that's why it is unstable, where this one is stable. Always we know that the unstable thing get converted into stable one. Always unstable one tries to get converted into stable one. That means, so what is this? Plus 2 plus 3 is nothing but oxidation. If it is undergoing oxidation means it is definitely a reducing agent. In the same way, if Mn, which is given, okay, Mn plus 3 is also given. Mn plus 3 tries to get converted into Mn plus 2. Okay, Mn plus 3 means it is also having 3D4. like this. So this is unstable. Unstable because it is having no half filled, no full filled, no T2G or no EG stability is there for this one. But Mn plus 2 is 3D5. What's the meaning of 3D5? It is having fulfilled stability. Fulfilled stability. Hence, always Mn plus 3 is get converted into Mn plus 2. Plus 3 to plus 2 means definitely this is nothing but reduction. If it is undergoing reduction means it is definitely a oxidizing agent. So this is the very important thing for fourth question. So that's why was that option 3 is correct. Cr plus 2 is reducing. Okay, Cr plus 2 is reducing agent and Mn plus 3 is oxidizing agent. Option 3 is correct. If you move for the fifth question, the question given that in which of the following pair, okay, the more stable than the second one, the first one, okay, more stable than second one, which is first one is more stable than second one. Just look at here. If in fifth one Mn plus 2 is given and Mn plus 3 is given, we know that Mn plus 2, Mn plus 3. What is Mn plus 2? 3D5. Mn plus 3 is nothing but 3D4. Was it 3D4? Which is stable? This is half filled stable one. So that's why option 1 is correct. Option 1 is correct for fifth question. Okay, right. If we comes to sixth question, which of the following are amphoteric oxides? Don't forget that we have some basic oxides are there. Okay, for the sixth one, few are amphoteric oxides are there. Amphoteric oxides are there, and few are acidic oxides are there, right? So always if amphoteric, okay, so if it is having low positive oxidation number, then it is basic. If it is has high positive oxidation number, then it is acidic. So the medium one always shows amphoteric. For example, if it comes to chromium, we have CrO, we have Cr2O3, and we have CrO3. Over here, plus 2 oxidation state, plus 3 oxidation state, it is plus 6 oxidation state, as we know that. So lower oxidation state is plus 2. Always lower oxidation state 1, lower positive oxidation state is basic, and higher oxidation state, higher positive oxidation state is acidic, where the medium one plus 3 is more than plus 2 and less than plus 2 is amphoteric. 1 is over. After, if it comes to the vanadium, we know that VO is there and also VO2 is there. Okay, vanadium, VO and VO2 both are basic, where we know that V2O5 was a specialty of V2O5. It is amphoteric, no doubt, but mainly acidic. Mainly acidic. After that, so no acidic vanadium oxides are there. If it comes to the manganese, MnO is there and MnO2 is there and Mn2O7. This is having plus 7 oxidation state, hence acidic. It is having plus 4 oxidation state, hence amphoteric. It has Mn plus 2. So that's why was the question, if we are choosing in the given option, if we observe the fourth one, Cr2O3 and V2O5, fourth option is correct for the given question. This is nothing but sixth question. If it comes to the seventh question, what is the seventh question is given? So just remember this information, so that we will get everything. If it comes to the seventh question, highest oxidation state of manganese in fluoride is MnF4, but highest oxidation state of oxide is plus 7. Because what's the reason? Okay, so generally fluorine can form only single bond. Just look at here. For example, this is the manganese having like this. For example, to get to plus 7 oxidation state, 7 bonds it has to form. 7 bonds it has to form like this. 7 bonds it has to form, but its surface area is not sufficient. That's the reason. Hence, it cannot form MnF7. MnF7 is not possible. But where in case of Mn is there, so just look at here, Mn double bond O, Mn double bond O, Mn double bond O, and O, or simply we can say that O minus MnO4 minus double bond O. In this situation, just look at here, with 4 oxygen only, its oxidation state is fulfilled by +7. So that means the reason is oxygen can form multiple bonds. In case of Mn2O7 is also same thing occurs. So that for manganese to get +7 oxidation state, 7 bonds it has to form, because fluorine can form single bond, where oxygen can form double bond. So that's why with 4 oxygen the given thing is satisfied. So that's why which option is correct? So the 4th option is correct for what? 7th one. If we go for 8th one, the basic character of the transition metal monoxide follows the order. The same question as we required. So we know that if we go for 8th one, we know that titanium oxide, after that vanadium oxide is given, after that chromium oxide, after that iron oxide. Here to here size decreases, so that metallic character decreases. When metallic character decreases, basic strength also decreases. Hence 4th option is correct. So this is the 8th question. If it comes to the 9th one, which of the following oxide is basic? Which of the following oxide is basic? So what is the meaning of basic? Basic means least oxidation state should be there. So least oxidation, okay, basic oxide. Basic oxide means its oxidation state should be low. Oxidation state should be very low. If we observe the manganese one, MnO and MnO2 and Mn2O7, it is having +7, it is having +4, where it is having +2. Least oxidation state, hence it is basic, hence MnO. Means what? 2nd option is correct. If we move to the 10th question, was that the transition metal with low oxidation state will act as the transition metal with low oxidation state. I already told you that low oxidation state means definitely that is basic. Okay, high oxidation state means definitely that is acidic. If it is medium oxidation state, that is nothing but amphoteric. So low oxidation state question is being there, so that's why basic is correct. So that means option 1 is correct. Okay beta, so that's all for today. Again we will meet on Narayana online assignment paper discussion, but not now, next 4th and 5th September. Till then, goodbye.